Okay, so I'm going to go through a number of more difficult questions involving spheres and cylinders regarding their volume or sometimes their surface area. And often these questions are either about, one shape is equal in volume to another. You might have a metal object, you can melt it down and turn it into another object. Or it might be a question of submerging one object in some water and what happens to the water. So we'll go through a variety of questions. So here we have a sphere, radius 18 centimeters, and we have a cylinder with a radius of 36. Okay, we don't know the height of the cylinder at this stage. Okay, a solid metal sphere of radius 18 is melted down and remolded into a solid cylinder of radius 36. Diagram is not to scale. Find the volume of the sphere in terms of pi and then find the height. And this is the key idea. If you know about one thing and it's being melted down into another object, generally speaking, you start off with the first object, you find out its volume, and since it is going to be equal, you're then able to use that volume amount and work out the unknown dimension. So, and in this instance, the unknown dimension is that height. We'll come to the cylinder in a moment, but for them, just to deal with the spheres first. Okay, we know the volume of a sphere is 4/3 pi r cubed. That's given to you in a formula book. If in this instance we know the radius is 18, so therefore we know the volume is going to be 4/3 times by pi times by 18 cubed. And as a multiple of pi, okay, in terms of pi, that is 7,778, 76 pi. And you don't actually need to know what that is as a value, okay. All we know it is 7,776 lots of pi. So that is the volume of the sphere. But the whole point is you're melting one down to make the other. So effectively the volume of one is the same as the volume of the other. So if we now work on the cylinder, we know the radius is 36. We know the volume of the cylinder is pi r squared h. The only thing we don't know is the height. So we know the volume. It's 776 pi. We know what pi is. We know what the radius is. It's 36. So its radius squared is 36 squared. As I said to you, we don't know what the value of h is, but now we do that reverse process where we're going to do 7,776 pi, and we want to divide it by effectively what we have here. So this section here, this is just a multiplier of h. So if we are wanting that works out as 1,296 pi. So that is what we're now going to divide our 7776 pi by. And when we do that, we should get effectively an answer that's reasonably straightforward. In this instance, we get the answer of 6. Okay, so this division here gives us an answer of 6. So we know the height is 6 and the units are centimeters. So if this was drawn to scale, you'd probably actually have almost be a disc. Okay, be quite a short space. Certainly wouldn't be as tall as the diagram shows. So the key idea was I worked out the object that I knew something about, something that didn't have an unknown dimension. I then equaled that to an object that I'm wanting to find out about, and I have one unknown, and I'll work my way through to find out that unknown value. So here's another question. It's almost exactly the same, but it's in reverse. So here we have a cylinder. Now we haven't got a diagram, but there's lots to be said for actually doing a diagram for yourself. So if we draw a diagram where we've got a cylinder of radius 8 and we know the height is 12, we can work out what that shape actually has. So volume pi r squared h. That's going to be pi times by 8 squared times by 12, which works as 768 lots of pi. And just very quickly, again, you could have that as a number. It's 2,412.74, blah, blah, blah. But there's no need to write that down. We've got it accurately as a multiple of pi, and that'll do. So that's my cylinder, but I'm now melting it down and turning it into a sphere. So we don't know what the radius of this sphere is going to be, but we know that the volume of a sphere is 4/3 pi r cubed. So we simply put in the fact that the volume is 768 pi. We know what 4/3 is. We know what pi is. The only thing we don't know is the radius cubed. So to get the radius cubed, we're going to take my 768 pi and divide that by 4/3 pi. And when you do that on the calculator, the best way is to actually write out 1 and then the divide button, and then you can use the fraction button to be able to do 4/3 pi. Make sure the pi is in the denominator, in the numerator. Some people accidentally leave it in the denominator down the bottom there with a 3. It has to be on top or it has to be outside. So anyway, when we work that through, we get 576. So that is r cubed. So what is r going to be? Well, we do the opposite of cubing, which is cube rooting. And when I do the cube root of 576, I get the answer of 24. This third example is a fairly standard question. You often have a situation where you will have one shape and you submerge it in a cylinder of water, and what happens is the water rises. You all know what's going to happen if you put something into some water, the water rises. Now, so what's happened is basically you've got this extra cylinder of water. It's risen by a certain amount. And what has happened is that the object, in this case the sphere, has displaced water. So what you see, what I've highlighted there in the green, that extra sort of height of cylinder is equal in volume to the sphere. So again, very similar to the first example. I'm working out the sphere volume. So we have a sphere that's been put into the shape. And we know the sphere is 4/3 pi r cubed. And for this sphere, now be very careful not to make mistakes here. The sphere's radius is 3. So when you work that through, we get 36 pi. So that is the volume of the sphere. And so therefore it is not only the volume of the sphere, but it's also the volume of this extra cylinder of water that in a sense has appeared above the original height. And so this cylinder, okay, and if we think about cylinder is pi r squared h, we know the radius, it's 6. So again, careful not to mix up which one is your radius. So in this case, it's 6 squared. What we don't know is the height, this height up the side. So we know that 36 pi, which is the volume of the sphere, which is the same as the volume of this little cylinder of water that's risen and has appeared as such, been displaced by the sphere. And we can work this through. Now this works out very easily actually, because we find that on the left hand side, that's 6 squared times by pi is 36 pi, and you do a division now, so I think you should all know what 36 pi divided by 36 pi is. We get the answer of 1 centimeter. So we know it's risen up a very small amount, just 1 centimeter high, which is that displaced water due to the sphere.